Hi everyone. In the given problem statement, container with most water. So we are going to given a height of a various length in an array. We have to find which container would contain the maximum water. So let us take an example. So we are going to given an height, let's say 2, 4, 8, 6, 1. Okay. So the 2 value would be something 4, 8 would be a little bit higher, 6 and again the 1. So we can have two pointers I and our pointer j. Value would be initially 0, j would be n minus 1. So here, right, if you have to say how much water it is going to contain, so 2 and would be 1. So this would be the area that is going to contain. So from 2 to 1, right, the entire area can be covered with water. Okay. So if I have to calculate it, then the volume would be minimum of 2 or 1 multiplied by, let's say, j minus 1. So in that case, right, 1 multiplied by, so j right now 4. So 4. So the volume would be 4 in the first case. Now, in order to maximize, what can I do? I can, out of the 2, right, which value is minimum? So j pointer value is minimum. So I can move it to this position. Okay, so I am decrementing the jth position by minus 1 because out of the both of the pointers, right, the j value was smaller. Now similarly, the volume would be now minimum of 2 or 6 multiplied by j minus 1. So in this case, the value would be 0 minus 3. So it would be 2 multiplied by, so 3, it would be 6. So now a question might arise, out of 2 and 6, which is smaller? So our 2 value is smaller, so you're incrementing I value by 1. Okay. Now same formula again, minimum of 4,6 multiplied by, so our current value is 1 and it is standing at 3. So 1 minus 3 would be 2. So 4 into 2 would be 8. This is right now the maximum value. Now out of which, right, 8 and 6, which is the highest. So our 8 value would be the high. So out of 4 and 6, right, the smaller value is the 4. So you're obviously going to increment it to 8. So minimum of 8,6 multiplied by j comma I, and it would be 6 multiplied by 1. 3 minus 2 would be 1, so value would be 6. So out of all of this, right, the maximum volume we got at 8. So this would be the way how we can tackle this problem, and you can understand by seeing this diagrammatical representation, right, how this is going to be done. So if in the first case, right, our value would be this one, this would be the entire water that could be covered. Now in the second case, right, because you're going to move this pointer to this position, so this and this position, right, the entire how much area of water could be covered. Now out of which, right, the smaller one would be this one, so we can decrement the jth position to this one. Then the volume could be this one. Then again, out of both of them, right, so which would be the smaller, so this would be smaller, so again you can decrement to this position. Then this entire area could be underwater, and out again, right, we can decide on which value to be, which one to increment. In case both of them are same, right, we can give some equation operator to tackle this scenario. So it is very simple to do. We just have to ensure that there are certain conditions that are met, so that we are always going to get an optimal solution. And using 2 pointers method, we can easily solve the container with most water problem. Now let us jump to the Python solution. Now let us initialize a variable called max volume, which is going to store the global maximum volume, which is going to be initially 0. And then we can have our 2 pointers I and j, which could be 0 and length of height or length of the array -1. Now we are going to loop it through while I is less than j. And now we are going to find the temporary volume in that area. So temporary volume would be, and we are going to use our formula, minimum of height of I and j, height of I, comma height of j, whichever is minimum, multiplied by j minus I. Now, if our temporary volume is greater than our maximum volume, then maximum volume would become our temporary volume for that part. And in case if height of j is greater than height of I, then we are going to increment our I by +1, and else we are going to decrement j by -1. And at last we are going to return our maximum volume. Let me click on run. There is some network error, it seems. Okay, now our public test case is passed. Let me submit the solution. And from here you can easily understand the time complexity would be big O of n, because they're looping through the loop the entire array one time. And as you could see, our runtime is pretty smooth and it is beating 85.07% of the submission. So we have written a pretty efficient code. That's all for this video. See you in the next one.